Okay, today we'd like to start the assignment 3. Actually, you should learn a lot of object-oriented programming techniques from this assignment. So be patient, just step by step, follow the instruction I will give to you. So from now on, we will step by step building up the fuzzy set theories, the library which can be used later on. I mean, for us to create a fuzzy inference system. So today I will introduce you probably some basic ideas of object-oriented technology in creating a complicated software. So start from a new project. Here you need to carefully select the project type. So make sure that you start from C#, Windows, and desktop. And within this selection, you need to carefully select the one. Well, actually, you can use some filter string here. What we are going to do is a so-called win form application. So you can take this keyword, this filter word, to quickly select, highlight the application type you want. This one is the one I'm just warning you. This is not the one we want. What we want is a Windows Phone application using .NET Framework. So make sure you select the right type of project, and then hit the next key. So you always start from the naming the project name. So what we have is R09, right? 09 or probably 10. 546-000 and your name and assignment 03. So initially, we just need to use your project name as the solution name, but in order to distinguish them, I kind of add a solution for naming the solution folder. Okay, this name will be used for naming the project name. But pay attention to location. If you like to retrieve it easily, it is better that you select your desktop. This is my desktop. So intended to create a project, and we just need to wrap up your project with a solution. Fine. Then the name is right here. Location. Make sure you put your everything in your desktop so that you can later easily to retrieve it. So for the .NET version, well, I think at least you should choose 4, .NET Framework 4. If your computer is kind of old, you can choose the 4.6, which is a stable version. If you kind of select your .NET Framework as 4.8, then probably your code will not be executable in normally Windows desktop, because usually I think for example right now I just have 4.7.2. So if your application is compiled using the .NET Framework 4.8, then it will not be able to execute it in my computer unless I have the source code and downgrade the .NET Framework version back into the one that I have in my computer. So make sure your .NET Framework version selection not too high. Otherwise, once you deliver your code to some other guy, if that guy, the Windows operating system is old, then it will not be executable. So pay attention to that. So usually 4.6 will be very okay for current or contemporary Windows desktop. It will be okay. So we just need to create this project for us. And since it's a WinForm application, so right now you need to change the default name. Don't let form1.cs remain on your project. It is not look professional anyway. So usually we start from changing the file name, not the extension name. Okay, file name. Usually in my convention, I like to change it to main form because this is the main user interface. So once you type the new name for this file, actually we just will ask you should it change the class name to yes. We like that. But again, make sure you change the title first. Don't let form1 live there. So what we are going to do is actually assignment 03, right? Assignment 3. Maybe you can put your name there. Actually, in assignment 3, what we would like to have is a fuzzy set. Fuzzy set. Okay, that's it. So, all right. So this is the basic use interface we have right now. So, in the last assignment, you kind of have a little bit experience about designing a class, right? So here, we would like to build a fuzzy set class. But you know, fuzzy set should be defined on a universe, right? So probably more than one fuzzy set were defined on the same universe, right? So if you think about the object in an object perspective, so probably we should have an object or universe, right? And if I am a fuzzy set, for example, I'm a Gaussian fuzzy set, the other guy is a triangular fuzzy set, and we are defining on the same universe, then we need to refer to the same universe. So object-wise, eventually we will create an object or universe, right? And then we create, user might create a Gaussian fuzzy set, it's an object. Create another triangular fuzzy set, another object. These two objects will be defined with respect to this universe, right? And in graphics display, they will be, I have a curved line, right? Triangular fuzzy set will have another line. So this line will be shown up on the user interface on this main window. So main window will provide a chart component for us, for fuzzy set, for universe, in order to display their characteristic there. So right now we need to do all this stuff programmably, not design in advance. So well, just be prepared. We are not going to do the design in the design phase. Some design stuff will be done in the code in the runtime. Okay, all right, keep that in mind. So we might start from designing the first class, should be the universe class, right? And if you look back into the slide, what kind of characteristic data our universe should have? Universe should have a name, right? For example, that should be temperature or pressure, whatever. So definitely, the universe has a name, and the universe should, when we display fuzzy set, right? There is a chart there showing up there, and you know, in a chart component, there are more than one chart areas can be specified by user, right? So it seems that a fuzzy universe should have chart areas, right? And if user like to display this fuzzy set, then chart area will be shown up in the chart. And also, for those fuzzy set defined on that universe should be displayed on that chart too, right? So think about the data required for universe first. Okay, all right. So we kind of start designing the universe class. So similarly, we start from the right click on this project tag, and then we will add a class. So right now it's about the time you name your class. The class name is an identifier or C# programming language, which means that it should abide by the naming rule or a variable. So in C#, a variable should not have a blank space. Okay, and it cannot be initialized with any numerical character, and can only be initialized with underscore. Other symbol will not be acceptable. So follow the convention in the .NET framework. We like to maybe name our class universe. So you tell the Visual Studio you would like to add a class. The class name is right here. So Visual Studio will prepare a C# source code for you. The file name is just your class name, .cs. And initially, this class is internal because there's a speed ID not showing up as internal. Internal meaning what? Meaning all the class within our application can directly use it. If later on, if you wrap up your class as a library to be sold, delivered to other customer, then definitely in that case you should declare as public. But so right now, well, let us prepare for that. So I will ask you probably you just set the accessibility of that class public. So right now we have a Universe class public. So later on, if a user like to build up a fuzzy inference system, probably he will define more than one universe, right? And we like probably initially user does not need to specify any parameter. We kind of create a default universe object for the user, and later on user will modify, for example, the name and the range later on by through some user interface we provided. So we like to have a default object or universe. So in that case, you should have you should design a constructor. It's default constructor. And in C#, if you do not design any constructor, the Visual Studio will prepare a default one. So default one is that a constructor without taking any argument and then without doing any initialization at all. So that will be okay. Once you define a class, there is no any constructor. It will be still okay. So for example, right now we have class universe, right? Nothing there. But if I have in my form, I have a button there. Put a button. And the name kind of btn create and create universe. Fine. So then I have what? Create universe, right? So it's so obviously, well, let me change a little bit. I really hate the font. Okay, the font it's called a min light, and it does not look good at all. So usually I will select this. Remember that it's a parent container. Okay, so if I change the font because it's min font, so I like to change it into the Jen Hay. Okay, fine. So that will look the appearance will look much more professional. Okay, later on you will see this font type is sans serif. There is no any serif there. Okay, so I have one created. So once user click on it, we subscribe this event by default. Double click it, subscribe this event. So create universe, click it. Well, in that case we will new universe. See, IntelliSense know that right now you have defined a customer class, so you can easily define a universe object. So right now we need to create the type. So right now universe is type, is the user define a type universe, my you, for example, like that. So it's working. Believe it or not, let us try it. So once user click it, right now we are in debugging mode. So check it. Take a look at the local variable right now. Within this function, we have local variable sender e, right? And also this one, my u e sender. How about this? Because this function is a member function, it's in particular is a non-static member function, or shall we say it is object scoped function. So object scope one can access its object data. So this is the object, or well, because a lot of data has been inherited from the standard form object. So once you unfold it, you will see a bunch of properties already there. You can search the one text, right? We change a little bit about the text, right? So take a look at text. This one is has been modified by us right now, right? It's assignment 03. So you know, once in debugging mode, especially when the execution up to a function, you should check the local variable right here, local variable. And since a function right now is an object scope function, so we can access the data of that object. So now we have main function object instantiate and serve as the user interface for our application. And right now we are in this member function for this guy. So this function can access all its property because it's an object scope function. But right now, how about my U? My U is actually is a reference to a universe object. But right now, it does not refer to any object. So initial value is none. So we call, we say that this variable is a reference type variable. Reference type variable do occupies a fixed size of memory. Usually that should be 4 bytes memory. So within this 4 bytes memory, later on, once it is assigned a value, that value should be an address of the memory. So we call this kind of variable reference type of variable. So remember that for C#, every class variable are actually reference type of variable. Initial value should be none. And once the computer dynamically allocate the memory for that object, then from now on, from that on, the object has data associated. So right now, this line has not been executed yet. Right-hand side has not been executed yet. So right now, my U is 0. And then if you hit F11 key, it is finished. But right now, my U has been instantiated. So take a look at right here. Well, as you can see, my U, well, actually, there's message came out showing up here. What you have is that universe. So actually, this is type, right? We just define this type of universe type. And the R, start from R up to just is a namespace. Remember that right here. We define a class right here. This class has been wrapped up by this namespace. So actually, if a user like to access this universe, he need to name this, need to describe this, namespace. So that is, so by default, my U, nothing. There is no any data defined, right? So there is no any data defined. But if I do define a data, okay, for example, I kind of specify a data string name. Okay, that's it. Name. And what about we should have double min, right? And also we have maximum, right? And also we have what? We have resolution. For example, start from 0 up to 10 or up to 100. And normally you will draw a fuzzy set probably using 100 point, for example, 100. And probably if you like to have much more smooth curve, and you might special 1,000 or 20,000. It's okay. So another data I might use probably call it what? int resolution. So up to this point, I just define data, right? And when I did not specify the accessibility, these data are private data. Okay. So I put it comment here. And in Microsoft terminology, we like to call it data fields. Fine, it's private data. So once I change the definition of this universe, let us see what's happened. Okay. So when click this button, okay, we are about to create an object, right? So up to this point, my U is none. When I execute this line, well, I hit F11 key. Nothing happened, right? Because there is no any statement needed in instantiation universe, so it's okay. So after I click it, check about my U. See, you have data associated with it. Maxima value, minima value. Name is none because it's string. String is a reference type. Resolution 0. Okay, fine, we know that. So it is better that we provide a variable initial value for universe. Later on, if a user create another universe, they can change that. So that is a convention we like to have. We are not going to put a text box, put a label saying that, okay, please specify your minima value, maxima value, resolution value, name value, and then hit button. No, we don't have so much space for the user to supply the initial value at all. We kind of like to define the universe has a default value there. So, okay, in that case, we might say, oh, all right, my initial value minima equals 0. So we kind of specify initialization there. So it's illegal, right? Maximum value should always larger than the minimum value, right? And the resolution probably be the 100 point. How about name? Well, name is very important. Probably we say, well, it's U. Okay, just U. Fine. So right now in your class you have defined data and also put some initialization statement there. So let us see what will happen. Click on it. We are about to execute this time, but this time I hit F11 key, trace into the function. Oh, wait a minute. F11, right? Let me check about, wait a minute. So let me see. Universe, right? Oh, okay, fine. Because this statement has been, wow. Okay, never mind. Let us go through it again. So if even I put F11 key, oh, okay, this time it's happened. So the code, the debugger has traced in to your universe. So right now memory has been allocated, right? So initial value, you see, take a look at this this value. Initial value has been initialized by the computer, so 0, 0, 0. But since I have this statement, initialization statement there, so it will be executed line by line. All right, so it's about to change the name. See, name is none, right? So once I execute it, U. How about the mean? Mean is 0, fine. How about the maximum value? 10. So right now maximum is 10. How about the solution? Is 100. So up to this point, your universe has initial value there. Okay, but how about if later on user click another one? All right, so fine, because this local variable, it is not pick up it, so it keep overriding it, so nothing happened. But we don't like the names share the same U. So in that case, we just doing the same naming scheme as the we just did. You see, when we drag a button in, right, the name by default name is button 1. When we drag the second button in your form, the name should be button 2, right? So we have to have similar mechanism in order to avoid the same name for the user to identify which one has been recently created. So we kind of use a trick right here. All right, so this is universe right now. So later on we will have a universe temperature, universe pressure, whatever, and the name can be modified by the user later on. We like to let them do that. But here, default name should be different. Right? So we can use, well, within the universe, I kind of define in I might call it a current count. Whoops. Equal 1. All right, if I define this data, then the data is object scope. Meaning what? Meaning every universe object has their own current count. But right now, I like to just let all the universe objects share this data. Okay, in that case, I will put a static. So right now, static is not belong to an object. Static is belong to this universe class. So we call it static data. So how can we use that? So every time a universe has been instantiated, then the counter will be updated by 1. So later on we will know how many universe has been created. So right now, this time I like to add a constructor. So constructor is a special function name. Is a special function, cannot return any data type, and even the void is not allowed either. And the name should be exactly the same as the class name. That is called constructor. So it's a special function. So if you like to have, if you like to add a constructor, you can use a shortcut. You just type a CTOR. It's a secret word, CTOR. This secret word only recognized by the Visual Studio. So once this secret word has been, this password has been accepted, has been identified by the IntelliSense, you kind of hit tab key twice. So Visual Studio will prepare. constructor, I mean skeleton for you. Well, you can try another secret word. For example, if I type if, you see, when if it is a secret word, it has been highlighted by the IntelliSense. So once IntelliSense recognizes this secret word, hit tab twice. We should kind of prepare this code snippet for you anyway. All right, so never mind. So right now we prepare a public constructor. User does not need to special any parameter. But right now I like to change my name. Name equal what? Equal sweet string. So this is sweet string, or we call it formatted string. So you cannot leave the you cannot have a space character between the red character came out, right? Okay, so it's a special, very special formatted string. I mean C#. So we like to U and then put a placeholder. Put a placeholder. A pair of braces mean a placeholder. Eventually, this string, this part will be replaced by the value within or evaluate from inside. So we kind of put what? Put current count there. So current count current is 1, right? So our name should be U1, and later on that should be U2. So we need to increment it later. We will increment. So we pick up the current count. Use that to name our name as U1, and then we update it. So current count turned out to be the 2. So next instantiation, the name will be U2, like that. Okay. So, all right. So let us take a look at what happened. So we add another constructor. F11 key, create one, right? So initially U is okay, 10 is okay. So this line will be, I mean, this line is initialization executed outside the constructor. This will be executed first. So take a look at this much very well. So initially U, right? And it's about the time we invoke this constructor, right? So we knew it, right? We invoked it. So within here, we kind of change our name into U1, U2 like that. So this time is U1. Next line. So we complete my U, the creation of my U. So take a look at U, when as U1. Okay, so U1 is U1. How about the user click second time? This time, there are trace in again. U. So initially is U, right? How about it? Move your cursor to the current count. It's 2 right now, right? So after this line is executed, how about the current count? 3. All right. So we will have a bunch of different object with different name came out. All right. So this is the whole idea we have to have, and right now it seems fine. But later on, we like to change it. We like to let the user change what? Change the name, change the mean value, maximum value, right? So how can we do that? How can we do that? And for example, if a user hit twice or 3 times, where did you keep that reference? Later on, we will show it up, right? All right, so it's about the time we introduce a very complicated control. We call it tree view. So this is called tree view. Name it. Use your own naming convention. For me, I like to TRV tree view, and that is actually related to your fuzzy model. FUZZYMODE, fuzzy model. Okay, fuzzy model tree view. Okay, let us take a look at the property or a tree view. Let us node. Okay, it's a tree view control contain several hierarchical arranged node. So if we will call, actually the class name is just called tree node. So they have a node, right? So feel free to try it. So it's a collection, right? Oh, can we add another node 0? You see node 0, node 1, node 2. So let's take a look at what happened. This is a node. So we like to take advantage of this hierarchical structure to display our fuzzy inference system. So node 1, well, definitely that should be the universe. Universe 1, universe 2, universe 3, universe 4. And within the universe, we will define fuzzy set, right? So there should be a second. You see, if I click on this guy, well, I cannot access it from there. I need to access from this TRV fuzzy model. So this is tree node. Okay, tree node. You see, right now where I have 3 nodes. So for node 0, node 1, node 2, they are separate. They are separate, brother or sister. They are on the same level, right? Who are their parent? Parent is this tree view. Okay, so if you take a look at the tree node, it's called tree node. The property of tree node. As you can see, the color. What color? Inch key. No. Probably that what came out from no. Huh. Check. Okay. Let me go through the nodes again. So we have nodes, right? Node 1, A to Z, Y. So probably that is hidden in the coding. Check it there. Nodes. Oh, okay, I'm sorry. Right here. Kind of forget it. So if I click on node 1, we can add a child. Okay, we can add a child, another child, node 3 or node 4. So they are on different hierarchy. Okay, remember that. So during the coding, well, if we so you can unfold this first label node. So we like to keep our universe in this label. Universe 1, universe 2, universe 3, and in universe 1, we can define fuzzy set 1, fuzzy set 2, fuzzy set 3, right? This is the sort of idea we like to have. So the problem is that the structure of a tree view really can hold our universe, right? So we like to put in there. And how can we do that? So once a user create a universe, we like to add that into this tree node. So you need to do some programming, dynamically add a node, to this tree node. To add a tree node object to this tree view. Okay, so let us just remove it. Node clear. Click on it. Delete it. Delete it. Delete it. Okay. So no. So within the interface, because this is the responsibility of our main phone, right? If you like to add something there. So once we got a new universe, my U, right? We will add that to the tree view. So what is your tree view node? Tree TRV, right? Okay, TRV fuzzy node. So we invoke what? Similar to the chart, right? Chart do have a correction property called series, and then we add it, right? Okay, similarly, the fuzzy TRV fuzzy model dot nodes, the property, right? Since it's a correction, each correction type data type always has add, right? But right now you need to add what? You need to add, well, you need to add a tree node. Okay, or add a string. Well, it seems that the easiest way to do that might be tree. Might be just put a string. But it is better that we add a tree node there, tree node. Okay, so before that we kind of instantiate tree node. Tn new. So we keep using the class in .NET Framework. So let's take a look at what kind of constructor we have. File constructor. You can say a text there. Oh, okay, just name, probably the name there. And if you have children, for this node, you can add that too. But this is not our cases. So and also you can put a small image associated with that node, which will show up in the tribute control. So far we might just add my u dot name. Right? We like to add that, but it will not going to happen. Later on we will see what's wrong there. Okay. So we like to put a name there, and then if you have tn, then we can add a tn. But right now we have problem, right? We have problem. Name is not accessible. Even though we have defined a name there, right? It is not accessible because it's private. It's private. If the data is private, you don't need to specify it. By default, it's a private. So in that case, how can you get the name? In old time, and especially, well, C# is a new language. If you are writing your program in C++, usually, okay. So from object-oriented perspective, it's okay. Data encapsulation. So data encapsulation, your data has been declared as private, but later maybe a user like to access it, to read it. Probably a user is not going to change the value, right? But the user might need to see it, right? So in that case, in C, in O C++ H, how can we do that? Oh, it's simple. You just provide a get function. So we usually get name. You cannot provide a function, and then this function will return a string back to you, and this function is public to everybody. See, it's a public function. So within this function, we simply return name. Excuse me, return name. So it's safe, right? Well, if anybody want to use it, I just provide a get name for you to do that. Okay, it's fine. And how about change the name? You see, remember that right now we kind of use U1, U2 as a default name, right? But the user try to build up a fuzzy inference system. He will change that into temperature, into change the pressure, right? So in that case, we need to let the user change that name, right? Okay, yeah, again, that's simple too. So we will prepare a function, does not return anything, and we call it set name. Well, what kind of new name you like to name it? You need to pass that new name through this parameter, right? So I call it new name, right? And here, within here, well, I just my name change into your you specify the new name, right? And this function must be public. So this is how a C++ programming do it. In order to accomplish so-called data encapsulation, which is an object-oriented paradigm. Object-oriented technology telling you that you need to encapsulate your data as private data. But again, sometimes user need to read it, so we provide a get. User might want to change it. You put a setter function there. So we call this setter. We call this kind of function setter. We call this kind of function getter. Again, currently, if you are using C++ programming language, in order to fulfill the object-oriented paradigm, you need to put a lot of get and set, which is really troublesome, right? So, but fine, it's okay. So up to this point, let us go back to our function. So we are not going to access the private data of my U. Well, I know you do have a get name. So I put a function here. All right, up to this point, we kind of improve our class, right? We did do the data encapsulation, provide a getter, provide a setter. But if a user, well, it's okay because if user set the data into empty string, it is not allowed, right? So usually a programmer will set up the data integrity. Data statement right here. Okay. So, well, if you see, you probably does not have this purple curly line. This purple curly line is generally not from the Visual Studio. It is from a plugin module. I have added a spell checking module embedded in my Visual Studio. So if I have a typo error, then the purple curly line will come out. So if you do not have this red curly line, it's okay. The purple curly line, so it's okay. Okay, so usually we'll check it out. So if you might check it out, if new name non-equal empty string, then I allow the name to be changed. Fine. Later on we will see this kind of mechanism from time to time. So right now, once the user click the button, we create an object or universe temporarily put in the my_u, this variable, and we instantiate a tree node. Use the name as the required name for this tree node, and we add this tree node to the tree view. Okay, so let us check the code execution again. Click on here, right? So my u has been instantiated, right? The name is u1, 0, maximum 10, this is 100. So right now, an tn is created. You see, there's a text equal u1. All right. So an object or tree node has been added. How about the node? The tree node currently is the count is 0. The count is 0, right? So it's about the time to edit. So we edit. Okay, let us see what happened. Continue. So right now we have a universe appear right here. All right. And then if user click again, this is a breakpoint, right? You can temporarily disable this breakpoint. Click on here. So we still have mark remain there. Later on you can retrieve it. So keep going on. So now U2, U3, U4, U5. Okay, good. But again, it kind of looks like a U1 has been special right here. So maybe user like to click this guy, and then you will pop up some text box to let the user modify, right? Because the name should be temperature U1, U2 should be pressure, like that. For example, for the user. So user needs to access this universe object and then changes its property, right? So this kind of it's kind of needed, right? So let us go back to our universe design. So it is old-fashioned. Get and set is an old-fashioned. So right now in C# we have a new data attribute we call property. And the property should be open to the user. You see, in order to encapsulate the private name, we kind of provide get, set, right? And we need to do some integrity checking if user like to change your name, right? So this kind of mechanism is a kind of old-fashioned. But since you are using C#, so you should add a property here. Add a property. So how can we add a property? It's just the format is just it's similar to a data definition, and in the body, again, it's similar to the function. So this is the property. So we can define a property called public. It should always start from public because we like to let the user access it. Public, it's a string, and then we usually name our property capitalized name, and then ME. All right, if it's the data, then it will end up by a semicolon, right? No, it's not a data declaration. It's a property declaration. Property declaration has a pair of braces, but within this pair of braces, you need to at least provide at least a setter or getter. Otherwise, the compiler can, you see, there's a red curly line came out. So you say that, well, property or index must have at least one accessor. Accessor meaning what? Meaning either getter or setter. Okay, so right now, because then I need to provide get and set, right? So I will provide a getter. A getter, the keyword is get, getter. Again, a pair of parentheses. So we put a getter right here, and also we provide a setter part. This is the skeleton or a property name. This get is exactly like the idea right here. So if user like to know the value of your name property, you need to return something back to the user, right? So why this recurring came out? You should think about that. Even though this is a get keyword and a pair of parentheses, actually these are a function, a getter function, similar to here. Why there is a recurring? Because you did not return anything. You do not have a statement here. So you see, not all code paths return a variable. So you need to think about that a property do have a name specified, but in fact, intrinsically, they are at most two functions, or at least should have one function. The function is a getter or setter function. So in the get, what we need to put is return lowercase name. How about set? Set always provide what? They should provide a new value, right? And the new value should have the same data type or your name, right? So here, the user supplied parameter has been sent to your setter by a keyword. They always use this called value. Value is actually is supplied by the user. Once user want to change the content of your property, so value is keyword. You kind of use your keyword assigned back to your name. Okay, this is how you do it. So we call right now name is a property. So we have getter, we have setter. But since the value might not be valid for your usage to name your name, right? So you see, we kind of check our integrity right here. If a new value is an empty string, I'm not going to accept that, right? So usually you should have okay, the idea is right here. So it's very important. In your setter, you need to check the validity. Okay, if value non-equal non-string, then I allow you to change it. So this is old stuff. We are not going to use it. So we kind of comment it out. So right now, I do not have this get name function. I have property. Instead, I have property capitalize our name. So let's go back to our code. So right now, there is no such kind of function, right? Okay, take a close look at what will happen when user creates dot. What is my U? My U is an actual universe right now. So your universe has, okay, right now you have a range, right? We know range is property, so you cannot define a public property. So right now user can access it, can read it, and can set it. Okay, so that's the whole idea. So we have a name. Available right now here. Okay, so we get a name. But again, there's nothing came out, right? Okay. All right, so we have property. So similarly, user might want to change what? Might want to change the value of maxima, right? So similarly, we will do such kind of property. But here, all right, so okay, let me use typing public double max. So I kind of MAXIMUN. So the property name, you do not need to specify the name exactly like the lowercase variable. Okay, so here in private, I kind of use a abbreviation max, right? But in order to open to the public needed to know the value, right? So I call it maximum value. So in that case, I have get. Because your get is just one statement, right? You just return this name. So if your get is so simple, your get function is so simple, there is no any other statement, just this return statement, you can simplify your getter by this function. We call this lambda expression. So I just put it on next. Okay. So once the user needs to know the current maximum value, it will through this get. And then how about the setter? So we need to check the validity, right? So we need to check what? If value is new value intended to change my maximum value. So if the value is small, then my min return. You can say that. Otherwise, the new value always larger than my minimum value, right? So in that case, I change my max value into your new value. So again, this is a guarding condition. Must be satisfied in order to let the user change the value. So this guys, the setter is very important because it will guarantee your data integrity is not broken. So we will declare the maximum property in this way. Okay, so similarly, if you should define define your own property by yourself. So try to make this minimum property come out. How about the resolution? The resolution is 100, right? So user cannot specify a negative value, and user should not supply a very small, for example, 10 point does not show up your membership function, right? So you might set up certain kind of rule in order to not violate your integrity. Okay, so that is the beauty of property, especially in the setter. So you need to put some effort in there. How about the increment? As you can remember, if we like to draw a function on the universe, right? We should have an increment value, right? So increment value should be what? Should be derived from maximum value, subtract the minimum value, and divided by the resolution, right? So think about what kind of property a user might need it from your universe. If I like to draw a line, okay, I know your minimum value, I know your maximum value, but right now I need to draw a line. I need to know even though I know you like to like the Father said display 100 point, right? 100 point. But how about the increment? The interesting data is the increment. I like to know, not the resolution, right? Okay, so in that case, I might declare another property called what? Public. I might call it it's double increment. Or I might call it delta. Well, delta probably is not good. Increment, INC, abbreviation. Fine. Increment. Fine. Same there. But in this case, I just have get. I just one statement. How can you get? Well, I use my maximum divided by my minimum divided by my resolution minus 1. See, right now you do not have increment data field, right? But this increment data field has been published to the public, so public can directly use that to draw the function curve, right? Resolution is kept by you, but later on probably resolution still be needed for the user to change that, right? So in that case, you need to maybe public anti-resolution. So getter simple return resolution. Oops. Resolution. Set it. Again, you need to make sure that. So, well, maybe I say if value smaller than 10 or value larger than 1000 point is not equal, I will return. Otherwise, well, resolution change into new value. Oh, excuse me. Okay, so up to this point, remember that we kind of add a three property: resolution, increment, name, maxima. You need to do it by yourself. Okay, I'm not going to cover that minima. So catch up the similar idea. Try to postulate your private data field into the public. So let us take a look at the object what we have right now. Well, let me use a breakpoint. Activate this pointer again. So again, create another universe, right? So up to this point, if you click on it, you see right now we have what? We have resolution 100, U2, 0, 10, resolution 100. So increment is 0.111 there, right? So even though we do not have a data field increment, right? We just have a resolution. This increment has been published to the public. Public can directly use your minimum value. Well, I'm sorry, I do not have a minimum value here. Okay, and maximum value and its increment. Draw the number of points, right? Required. Okay, so up to this point, let me just finish because we still need the minimum value. So I kind of all right. So in here, Wizard can help you encapsulate your data. So how can you do that? So if you kind of highlight the mean value, right click at the bottom, there is a quick action and a refactorings. So and within this selection there is a option encapsulate data field mean, but still use field. Still use field is minimal because you have some code, right? There has been using the lowercase, you have been access the data field directly, right? Right now, if you let the Visual Studio encapsulate your private data field into the public, then it might be changed. So make sure you select this one. You still can use this one, it's okay. But we prefer, within our function, we directly use the data field. It's much more efficient. Okay, so click on this guy. You will get this line. You see, it's similar to the property declaration, right? But by default, they do not specify the set as a serious set function. So usually, Wizard help you write this code, right? So we kind of will arrange a little bit. We will arrange it a little bit. The most important thing is that we try to create our own setter, not the default one. The default one does not provide any integrity checking. So now here we need to make sure if value large than the smaller than the maximum value, then only in this case I change minimum value into your new one. So remember that the value, well, is the value that user want to change it. Okay, so they always use this keyword. All right, so maybe we sure about the time to change it. So right now we have all kind of property ready for us, right? So how can we let the user change this parameter? All right, so go back to our code again. You see, when we create an object or the universe, we create a tree node, right? Tree node right here. Let us assess a little bit about the Tn. So right now we have an object, right? My U is a new object. It's a universe object, right? And then the tree node is another object. This object will be attached to the tree view control, right? So take a look at Tn dot. There is tag appear here. Data tag, you see, once you see this guy, as you can see right now, you can see there is a process indicated that tag is a property. You see, there's a getter set there. So that is why we have range symbol as icon. So tag is a property of what? Or tree node. Tree node has this tag. Data type is an object. Since it's an object, so it's a reference type. The value can store any kind of object. Well, so it's about the time we kind of hidden our universe object, put its reference into this tag. Then later on, once the user click on this tree node, then we know user try to access this universe. All right, so Tn dot tag data type is object. My U put in there. It seems a little bit weird, right? My U is a universe, but tag is an object. All right, the story is that even though you design a universe class, right, you did not inherit any other class. This means inheritance. But all the class, means within the dynamic framework, are intrinsically inherit from OBJECT, which means that even though we did not declare that, but actually, all kind of objects are implicitly inherit from OBJECT. And when you do that, as you can see, if within your function, your constructor, the OBJECT is a superclass. The OBJECT has 4 functions can be overloaded. So let us take a look at here. So if we create an universe right now, so we have my U ready there. So if you move your cursor to my U and then click on it, all right. So you cannot see anything, right? Fine. Okay, let me go back to the code. So my U is an object. Once you click on that, you can see that, well, this is a property we just added, right? What about this function? ToString, I did not write it, right? Get type, I do not write it. Get hash code, equal, does not write it. These 4 functions are actually inherit from OBJECT. So these functions are the 4 function, of the object class. So since every class, the class is defined that I intrinsically inherit from object, so you already have these 4 functions ready for you to use. Okay, and this function actually can be overwritten. Okay, so let us see what will happen. All right. So right now our universe, I do not do any. We have a property, right? We have a constructor. We do not define any function, right? We just have a constructor. So if the user create an object, then what we can access is that the constructor, right? But take a look at your the value shown up here. You see within this parent parameter, you see there's blah blah blah. This is a data type. This is namespace of your data type. So usually we will what? We will override. Since my universe, even though I did not explicitly showing that I inherit from OBJECT, but it do inherit from OBJECT. But right now within my class, I can override function OBJECT. So how can you override it? You simply just type a secret keyword override, override. So once override keyword has been catch up by the IntelliSense, what you need to do is that type of blank space. So IntelliSense will pop out those virtual function of the object, okay, can be inherited, can be overwritten by the derived class. So right now, my universe is a derived class of that object class. So I can override the two string. So let us override these two strings. So that means every object of certain kind of type, they always has a two string function, right? So if the user or sometimes the system like to show the content of that object, it will always invoke your toString. So right now, I like to override the toString by showing, well, this is a universe, my name is what, like that. So you can retain this string back. So I like to retain my string as a string, and then universe. My name, put in there. So this is my overriden function, universe name. So let us see what will happen. So you kind of override these two strings, right? Okay, so once my U has been instantiated, take a look at here. You see, my universe colon U1. So this is the visual data system. They try to display the content of your object, and your object do have overwritten the toString, overwritten string, because you special. The default toString just putting out the namespace of your class name. That's it. So it will be help you. It will be very helpful for you to understand, to realize what kind of object you are dealing with. So right now we have my U ready there, right? So increment property data, and then we have we have static member, right? Yeah, there. Okay, fine. So we kind of spend a lot of time in designing the property, right? So how can we use it? And again, we still did not solve that problem, even though we keep the okay. Let us see. Let me see right here. All right, so we put a take here, take a name, take my U. Okay, up to this point, fine. All right, okay. So it's about the time we introduce a very useful control. Maybe we have all right, so never mind. Okay, so let us introduce a very important control called property grid. So we drag a property grid in, property grid. Okay, property grid is a very powerful user control. If you can remember, once in design phase, if I click on a button, right, the modifiable property or button will be light up right here. Let the user interactively change it, right? So this property grid is it's similar to this one. So let me name our property grid. PRG property grid selection. This the most important property is should be here. Selected object. So right now we are in design phase, right? And if I kind of this property grid try to show the property of this button, so then I can select that property. Selected object. I kind of in design phase set it to the button create and universe. You see, it look exactly the same. Property of this button, right? This property is right here. So let us see what will happen. So in my using phase, I add a property grid here. well, what am I do? What am I looking? Is a property of this guy. So I can dynamically change it. So for example, if I change the text, right? Kind of change it during the runtime. See what happened? So the property is that, well, property can be modified dynamically by the user through this property grid, the color, right? So that is the whole idea of a property grid is using. Since right now we have defined property on the universe class, so we can populate this property into the property grid. Then the user modify it. Nice idea, right? That's the whole idea. So okay, it's good. So then, well, what we need to do is that, well, so initially we need to dynamically set the selected object labels. So clear, reset it, clear that. So when user click on add a universe, an object or universe has been instantiated, a node has been created, tag has been put in there, and then has been added to the node. So later on, user will be interactively interact with this tree view, right? So let's check the property of this tree view. So we have after select. It's a default property. Yeah, after select. So after a selected node has been changed, right? So we subscribe the tree view fuzzy model after select right here. So this event handler function is a little bit different from the button. Button is very plain, so the does not have much information in this argument. But right now we do have rich information right here in this argument. Either let's check node, which node has been selected. So this node is that get the tree node that has been checked, expanded, collapsed, or selected. Oh, okay, this one. This is the one what we have. What we like. Okay, so we know it's a tree node, right? Tree node, right? So if a user click on the universe, right? So we need to know the universe, right? So how can we access the universe? Because we have been secretly hide our universe into this tag, right? So we can easily pick up this tag tag, right? All right, so right now we take out this object, but actually this object is a universe, right? So this object is a universe. So now we can set this tag into what? Into property grid PRG selection. Reset is a selected object. The whole idea is that in this way. All right, so let us set a breakpoint here. Let us see what would happen. So initially click a guy, right? Keep going. Has been added, right? The second one, keep going. Third one, keep going. Right? So up to this point, the property grid does not show any property, right? So if I click on this guy, second guy, so we are about to execute this event handling function, right? So how about the tag? You see, you move your cursor to this node, U2. How about tag? Move your cursor to here, tag. Wow, universe U2. It has been hide as an object, not the universe, right? As an object in the tag. But right now we know if user click on this node, we can get the universe from node tag. So actually, universe is right here. It's an object. Again, it's an object. So object can be assigned to this select object. That is the whole idea. So currently, select object is none, right? Once this line is executed, right now select object will show the property of this universe U2. So let us continue. All right, this is your property, right? This is your property. You can see, well, I have a name U2 right here. Minimum value, maximum value, resolution, increment, read only, right? Read only. If I kind of change it, see, the maximum value I change it into 100. And then move your cursor to another place, activate this change. All right? but it's not updated, right? If you click on it, it will update it. Right now it's 1. Okay, fine. So that is the property. And how about the value setting? So let me set a breakpoint right here. So we like to again change the maximum value again. Right here, let me set a breakpoint right here. And how about the mean? Okay, so user change its minimum value, probably change into 500. It violated your integrity, right? Minimum value should not larger than the maximum value. So now it's 500, right? So user try to change, try to use this value to change your mean property. So if I click on another place, try to activate this modification, the execution came to this set. It's a set because the user about to change your mean value from 100, from 0 to 500, right? So where is 500? Move your cursor to here. The value 500. The one user specified in the property grid is a new value. Try to change your property. But right now your integrity checking statement is right here. My current maximum value is just 100, but user try to change my minimum into 500. It is not allowed. So this statement will not going to happen, right? Nothing. You did not satisfy the qualification about the value change, so nothing happened. So then what will happen? Let us go back. So what will happen? Still 0. It's okay. Again, if I type 101, move to another place. Let me disable this breakpoint to let you see what will happen. See, still 0. 100, 0.2. Enter. Once I enter, come back to 0. So the guarding condition is activated by your set function. So you need to do that. I mean, it's very beautiful. We kind of there are parameter display as a property and put in the property grid that the user. We do not need to provide a bunch of label and a text box and check the text box value. We just set them as the parameter and then use the property grid to display the value to let the user interact with that. So you see, this is U2. How about U3? So now it's public grid of U3. How about go back U2? We have changed it into the maximum, right? So we kind of take advantage of this public grid to let the user modify. So probably right now U1, right? Right now U1 try to change the name, change it into the temperature. It's okay. It's okay. When user click on another place, well, it's pity, right? We might expect that, well, this node, this text should be changed too, right? Should change it to the temperature, right? Well, I just let you try to solve this problem, okay? Ask yourself, try to explore more functionality with this guy. The idea is that once you change it, once a property change, then we need to change the node name or node text somehow there, okay? So what will that be? It probably is you can subscribe the event right here. Or yeah, it's better because that is related to this control. These two control management by the main phone. So we had better subscribe this event. And if the property is named, then we need to go back to here, do some change, right? Okay, now think about that. I mean, you guys should spend a little more time on on the property of this control. Okay, if you if you are not unable to solve this problem, maybe next time or later on, I will show you how to do that. Okay, fine. Okay, so far our universe has been successfully designed, right? So later on we will try to wrap up our fuzzy set. We will create our fuzzy set class, but not sure be the class or family. Okay, it's not just just an individual class. It should be a family or fuzzy set class. So we will come back with that design later. Okay, in order to reflect the newly changed name on the tree node, so that the easiest way probably should be this way. Okay, so maybe we should have what? We should keep a tree node in universe. So in universe, we kind of have so it's not recognized because we did not use in our namespace. So we should use using system Windows start form. So wizard will add this line for us. Add this using for us tree node. I call it the node. The node. We are not going to well, set up as a property, okay, because it's kind of hidden. But we should set up a secret, a public function. We will say, well, as a public set tree node tn, for example, and then the node equal what? Tn. Okay, function should return value. If we no value return, you should use void set return. So right now we have public function can be used. So how can we use that? Well, okay, when the main function instantiated u and the main function increase create a tree node, put a tag there, and then kind of change the reference, which is others. So node can recognize a universe via its tag, and then the universe object have tree node can recognize that. So in that case, it will be better. So in that case, I will invoke the my u set tree node tn, so that both of them know each other. All right, it's kind of idea simple. So then we go back to the universe, right? Well, if user changes the name, is via this property, right? This property setter name has been changed. So once name has been changed, if it's not 0, the name can be changed. If it changed, then we use the node dot, not tag is ourselves, text equal what? Equal name. Alright, so this is not the best way, but it should be the easiest way to do that. It is not cheap, okay, because you kind of add a pointer, add a reference, to each universe. But again, it's okay. At least we can let this user interface interact, which it does, no problem. So suppose you use a change temperature. All right, you can reflect that because this universe is a little bit associated with this node, so they can share each other. So again, add another 2, another 3. Oops, what happened? So this one might be the pressure, right? This guy might be what? Force, somehow. Okay, fine. All right, so up to now, seems okay. We can take advantage of this tree view control, store our universe. And how about the charting, right? Charting. As you can remember, well, we want to display the fuzzy set as a members function on the universe, right? So universe definitely should have a chart area. So we need to let the chart dynamically add what? Dynamically add the universe, add area chart there. So let's go back to the universe. So once universe has the tree node, similarly we will have what? We will have chart area. Chart. Chart area is located in another namespace. So we'll let the Visual Studio help us. It is stored in the Windows form data visualization charting. Okay, so using. Okay, you need to pay attention to that. This web namespace. No, we are not going to use web component. We should use system Windows form data visualization charting. So this is guy. So we just add this namespace for us. We call it the area. All right. So when we create, okay, universe. Where is universe constructor? Right here, constructor. So we when we created the chart, the area, the chart area will be dynamic instantiation new. We kind of new chart areas. Chart area again need a name because the chart uses name, so we kind of use our name there. Put in there. Okay. And then we need to add the so universe right here. We do not need it. And it's about the time we add these chart areas to our well. So we create this chart node. The area do have a name. Right, do have a name. It's okay. So right now we try to combine our universe, with the chart areas, and the chart area need to display on the user interface directly, right? So we will ask this constructor, well, this is not the one we like to have. We need to accept a reference to the chart. So we might ask, well, we should have a chart. Okay, so once we create this chart area, right? This chart area, then we will add that the chart areas. Add the area. So we'll do that by ourselves. So the main phone needed to provide a chart places for us, host for us. So we create a universe, then we will create a chart areas, and then show the chart area right there in that chart. So we kind of change the constructor, right? So your code, we're not going to execute it anymore, right? Because you have error. Because in our main phone, we cannot use constructor, so problem is right here, right? So about the time we populate our user interface with another chart, so we kind of add our chart here. It is on the data category. So we have chart coming here. So we make it clean. We make it clear. So change the CHT fuzzy set. No fuzzy model. All right. How about the chart areas? You need to clean the series. Remove. How about chart areas? Chart areas. Remove. Okay, so it's just chart for this. So in our code, we put CHT fuzzy model there. Okay, and probably you will not see anything. Okay, let me see. So my universe created and tree node add So this time, let us check the constructor right here. This is our constructor. So user click on that. It's about the time the chart area. You see, move your cursor here. The chart area count is 0. So right now we add this chart area in it. So right now chart area is 1. So theoretically you will see it pop out, right? But nothing came out. Why? Because the axis of this chart areas has been set to auto, and since there is no any series, so no any chart component will be showed up right here. So we need to do something. I mean, in constructor in your universe right here in universe. So we kind of create a chart areas. Right, the areas has been created. Okay, in previous assignment, we do everything. We do all the setting, property setting, right, via this user interface. But right now we are not going to do that. We need to do it in the programming. Okay, via the programming. So we kind of start from programming. The area, right? Right now it's focused on specific area. So once you access it, you see the similar property will pop out. XSX, right? Enable, see, enable. It's an enumeration. It's an enumeration. Just select it. It says enable. Select one. We should use true. Right. The area X, Y. Enable. Again, true. So make sure these two axes will pop out, even though there's no any series, right? So chart area came out, right? How about the second one? Area 2, third one, fourth one. All right, fourth one, sixth one. So one by one is dynamically added to this chart. But it's poor, right? There's no any indication about what kind of, at least because U1, right? U1, at least it's showing U1 right here, right? So it's about the time we seriously consider about this property. This property name, we define it by ourselves. But for a chart, for a chart area do have a name, right? Chart area have a name. The name should appear in the axis, right? Okay, and how about the minimum value? Minimum, we can set the axis minimum value, minimum value, right? Okay, so let us come back to the whole idea is that we have chart area created. We have axis, so the area axis minimum value is a property of axis. So maybe we do not need to so we like to set it. Okay, so we will let's change the name first. Axis name, right? Title name, right? Axis name. How should we set it? Okay, so we create chart area. So in this case, we do not need to special our name, right? You see, initially we have what? We have a lowercase name. In the constructor, we call it this name. But what we should say? So we should what? We should let this chart area instantiate when the so we need to do the initialization. The right here, we let this chart area initialize it when the class is created. So right now we have the area. Then we don't need to have this name, right? Since it's object, this object has a name associated with it, so we don't need to have a name specified. But how about the name? So right now we will have a name probably showed up right here. So we'll return what? Return our name is the area, right? So the area name, access name, chart area, the access title, not name, right? Okay. All right, it's title. Fine, title. Just change the title. No, title. Yeah, title string, right? Okay, and even that value. So again, the access title will be updated. And then this time, it's changed. The text now has been changed into value. Very same. So we still can use this title. All right. So value, which means that this means that we do not need to have data field name. Name directly pick up from this big object because the area has an access name, right? So we already use that. So how about the universe, right? Universe right here. We kind of use name toString, right? This is toString. How about the constructor? Constructor update our name, so we don't need to create again. So we will say that the area XSX name title name equal this guy. Yeah. All right. So change that into this name U1 U2. So we have a name associated with that. And in this time, toString we use our capitalize publish the name. It's very simple. Alright, the whole idea is that you need to do the rest by yourself because we have minimum value, maximum value, right? It's a data field, but actually you don't need to define that because the chart areas has an XSX has minimum value, maximum value there. So you need to directly report that minimum value and maximum value. That is better, huh? Okay, so what we can do is that the area, since it has been created, right? So we came back to this universe instantiation. We have this way value, initialize value, right? Enable to, well, actually we can move it to new part. We kind of do initialization right here. So the initialization is that the areas access x minima equal what? The initial value. This is the initial value. Maximum value is 10. It's our convention, right? And resolution is another story. We needed that, and name has been updated right here. So this is our constructor. So try to make your maxima disappear, just like the one name I have done, right? So you can do that by yourself. Can you to make your class design much neat? So in that case, we have what U1 defined. Nothing came out. Okay, so U1 has not been specified yet. What happened? Okay, let us trace. Our initialization is here. My universe one. Constructor right here. This is the name has been specified. Let me see what happened. Okay. XX. So we have X name U1. Our name the area access title. Oh, excuse me, not title, name. Made a mistake. I think that should be the title, access title. So I should access title. Excuse me. Let me change it. Title. Right. So the name probably should return title. No, the text equal value. Good. So this time, I mean, if we take a close look, actually the name of universe has been picked up directly from the chart area's access title, not our own defined data field. So similarly, minimum value and maximum value should be done in the similar way. Otherwise, because you have access minima and you have your own minima, then it's really troublesome to maintain this integrity. We like to have our data just singleton. Then that will be much easier to maintain. Okay. So right now it's obviously right now when a universe is created, we have U1. We have named U1. U1 named this XSS, right? So if I click on U1, so I can change the name right here, temperature. So actually, what we are going to change the access title right here, right? So once click on some other place, so that will make everything consistent. That is the idea we want to have. So you should do the similar things with the minima and maxima. Okay, so I will let you do that by yourself. So you are in your universe, this is not required. This is not required because the access, the areas accesses has its minimum value and maximum value. In order to make them consistent, you should remove this one, and then since we minimum and maximum has been published to the public, right? So right here, so actually you are not going to get not going to get the message. You should return what? The area XSX maximum value. How about minimum value? The access minimum value. Alright, so how about the minimum value? Needed to smaller than our, this time you can use this one or directly check this guy. And probably we should change that. Rename minimum. Okay, so maximum similarly. If value smaller than the SS minimum, return. Otherwise, we change the maximum value. So we're not going to use our own data. So in this case, user can directly modify well, for user, the user just change the universe minimum maximum value. So we don't need these two data anymore. Clean up some coding. If you have error, always deal with the first one. Yeah, we still have here increment. So increment start from where? From the chart, the area, access maximum value minus minimum value. But resolution is your own data, right? We need that. Okay, U1, U2, U3, U2. So user should this probably change the property. And they can change the minimum value into minus 100. It's okay. So a little bit changed too. How about delete? Once you delete it, right? It's very simple. Just this node has been removed, but your chat area should be removed too. So later on we will try. But think about it. I mean, in this moment, maybe you can deal with that by yourself. Okay, so up to this point, probably the universe has been we might, since chat area is maintained by this universe, right? So we have better in Constructor. We should make everything look good. The area access y title equal what? Membership degree, right? And how about its maximum value and minimum value? Well, I might prefer you start maybe from minimum value from 0 minus 0.1 up to 1.1. So it will be much better. Okay, fine. Not x axis, y axis. So just make the membership degree specify correctly. All right, U2, U3 degree, fine. Okay, it's about. I think that will be all for current implementation about the universe. So later on we will step into the fuzzy set. Okay, we kind of finished the universe class design. Right now we are going to design the fuzzy set class. And as you know, probably you know the differences between class. Just the difference should be the number of parameters, right? And the parameters name too, and also the function, they are different. But for the rest of them, the behavior or property should be the same, right? So it is about the time we design a family of fuzzy set class. Later on, we will show you the inheritance stuff. Okay. So right now we kind of start from designing our genetic fuzzy set class, and then we will say that Gaussian fuzzy set inherit from the genetic fuzzy set. All right, so we start from adding a class. All right, this is our project, the solutions project. So we start add a class, and I might call it genetic. F-U-Z-Z-Y fuzzy set, genetic fuzzy set. You can name your own class, it's okay. But so far, just like I mentioned, make it public. It will be much helpful. I mean, for later on usage. Okay, you don't need to change the internal back into the public. So we have a public genetic fuzzy set. And how about a data field? Oh, okay. In C#, if later on you will see our definition of class is quite lengthy because we will add a bunch of code in this class. So we can use a grouping mechanism, try to wrap up, fold together or unfold some code. So this directory statement called always start from pound sign region. So I might call it data fields, and I always end up with another directory called end region. So later on, we can fold these line together and unfold it. So we will have data what? Data field, right? So double parameters. It's an array. Right? We have array. But if you can remember, we have static parameter name, right? We don't need that anymore, right? We don't need that anymore. And there's a story. I mean, as we say, parameter right now is private data. So private data can be accessed only by the function of this class. not for the derived class. So even a class inherit from the okay. So right now I'm within here. I kind of try to save some space for you to make a reference. Okay, so I add another class right here within the same file. Okay, this is same file unit. This file should be the generic file set. So I kind of add up my first derived class right here to let you see the inheritance. So I might call it Gaussian. Inherit. This inherit syntax. Inherit from what? Generic file set. Okay. So if I instantiate an object Gaussian file set, I already inherit the data parameter from the generic data set, right? But you cannot directly access. For example, if I have a function, arbitrary function, I try to get parameters. Nothing came up. PRN intention will not allow it. Even though I inherit this parameter value, but it's private. If I declare that as public, right? So if I declare that public, so even though I have already have this parameter, I cannot directly use it. I mean, in my function. But right now, if it is public, then I will see parameter. See, I will see parameter. So it's really troublesome. We say data should be encapsulated as private, right? But if it is private, it will prevent the data access from the children class. So I can access PIN parameter. I can access. So usually in this case, if you are designing a familiar class, you should declare data as protected. Protected meaning what? Meaning these data are protected within our family. Outside our family cannot access. For outside classes, these data are treated as private, but not for the children, not for the derived class. Okay, so if it declared as protected, then in the function of the children class, I can directly access PIN. So always declare the accessibility of your data start from protected if you have a derived class or derived from this class. Okay, remember that. So right now, generic file set is a superclass for our family, right? So I will declare my property as protected. Okay, so they do inherit. But as you know, for a file set, usually should be defined on a universe, right? So we'll create that. We should have a universe. UNIV as universe. I call it the universe. And can be accessed from my children directory, so I call it protected. And not just declare that I have data field. I also, okay, this part region. Construction or constructor and the region. So I ask help from the intelligent CTOR, right? Tab key twice, but you should enforce. If you want to instantiate an object or generic file set, you need to provide me a reference refer to the universe, because file set always defined on a universe. We need to refer to that. So I will ask university UNIV. So the first thing is that I kind of assign the universe from here, right? So a constructor or generic file set, the purpose is that I try to accept the universe, then assign to the universe. But once we have this constructor specified, right? As you can see, Gaussian file set will have trouble, right? So move your cursor to this red curly line. So now there is no argument given the corresponding to the required formal argument universe, right? Because what? Because this class inherit from this generic class, right? But generic class, the constructor needed to have universe. So you need to provide a constructor that supply a universe to the parent parts, because you inherit parents' data, right? And then in the parent needed this universe to initialize the universe value. Okay, so I have to define my constructor or my Gaussian fuzzy set. So this is my Gaussian fuzzy set, my constructor. In this case, because parent constructor or the parent need a universe, right? So I needed to define it, pick it up from here. U, maybe I just call U, fine, it's okay. And then pass that U into the constructor or the base class. Base is a keyword, which means that because this guy inherits from this guy, right? So this base is actually this guy, the constructor. So we kind of invoke the constructor or the parent class right here through this base keyword function call here. So since the base have this constructor, right? This constructor take the universe, right? And right now we have a universe U ready for it. So I pass the U into the parent constructor in order to construct construct the universe here. So that is the requirement. If your parent have this only have this kind of constructor, you need to prepare your children's constructor to call, implicitly call as parent constructor, and has the same signature. Only in this way, the children constructor invoke parent constructor seamlessly. So that will make this object, children object instantiation success. Okay. All right. So seems like that. And how about genetic fuzzy set? Usually we will, as I described in the instruction, saying that well we have fuzzy set, right? And fuzzy set class. Virtual functions, okay, probably we have talked about that. It's about the time we talk about the function, right? Function is different, right? Number wise will be different. So for example, right here, Gaussian fuzzy set, what should we do? Well, remember that this is the constructor or Gaussian or the derived class, right? Parameter right now is protected, so I can directly access it. Parameter, right? Instantiate with two variables, new, double, 2. Right? This is the constructor or Gaussian fuzzy set. For the other fuzzy set, you need to do that by yourself. So some of them might need 3 parameters, some of them might need 4. So you need to do that by yourself. So each constructor deal with their amount of data by themselves. Fine, it's okay. So universe is okay, parameter is okay, and as I say, usually always provide default value. So my default value, parameter 0, 0, start from 0.5.0 because my initial value for the universe start from 0 up to 10. So I kind of parameter value is 0 there. And probably you can use a random number generator to make them different, okay? But it's okay, I'm at this point, all right. Parameter 1 is standard deviation, right? Standard deviation. For example, 1.5. All right, so always make a default value there. How about a name? Well, again, we will have a name. Name-wise, probably we don't need that because as what we have done in the universe, right? Initially we have a name, but eventually name will be embedded, pushed down into the access, right? For now, our generic fuzzy set, we should have another data related to the curve, right? So it's not okay because series is not always instantiated because later on you will see. Sometimes we generate a fuzzy set, but we are not going to show the membership function at all because a fuzzy set might be an intermediate product from arithmetic operation. For example, fuzzy set 1 intersect with fuzzy set 2, right? So after the intersection, we have intermediate fuzzy set. We are not going to show up this line because during the fuzzy inferencing, we might generate a lot of intermediate fuzzy set, but we are not going to show up the line. So series, we need that data, but only when we need it. We need to visualize its membership function. We populate the data. All right, so we have collected data series. I call it the series. It's not recognized, right? Okay, fine. Move your cursor here. There's a helping hand. Series is located within system Windows Form data visualization charting. So later we just add this time for you. So we have series. Initially they are all none. Okay, initially they are none. But the universe definitely we should have it. So it's initial right here. But we provide another property can be set by the user. Okay, because even though right now we always show the membership function, but normally, I mean, for this during the computation, we are not going to show up the curve because that will use up a lot of graphics resource and slow down your computing. So we are not going to populate the point or the serial point usually. But if user turn on that flag, then we will populate it. So by default, series is none. We are not going to show it up. But we will provide a property. So this is data field, right? So we will provide region properties and the region. So we have property. It's a public, definitely public, always public bool. Show, we call it show curve, show membership function, show membership function curve. That's it. And since so we will have a setter if value is true. Okay, if it is true, otherwise it's false, right? Else. So if value is true and if the series is equal none, that means it is not instantiated yet. So in this case, if it is none, then we'll instantiate the series. The series, new series. Okay, and then you needed to set the chart type, right? Chart type equal what? Enumeration line, right? So again, you can put some coding here to beautify your series anyway. And once it's okay, then what should we do? We need to populate the point, right? We need to populate the point. So if the value, if it's none, we will populate. We will instantiate the object and also add the point, series point. All right. So start from what? Maybe we should wrap it up as okay. We wrap it up as a service function. Okay. So here region service functions. I call it void. Okay, private function. Populate membership function point. So basically, because it's series right now, we have it instantiated. So the series points clear. Okay, series point clear. And how about the resolution and the increment? Well, remember that you have the universe, right? So we start from 4 double x equal what? Equal the universe minimum value, right? Minimum value. You know, the universe has minimum value, and x equal small equal then the universe maxima value, right? X equal X plus what? The universe increment, right? Increment is property, right? All right, so we kind of access that, and then what? We will prepare a point, right? Edit. So we prepare a double value y value. So y value equal what? Equal get membership degree. It makes sense, right? If I give you X, you should give me membership degree, right? So where is the get membership degree? We will define that function. And especially since this is a generic file set, we will make this function virtual. Okay, later on we'll see it. So once we have Y, then we will populate the series point. The series points add XY. We invoke add XY, put X add, Y add. So when this function is called, the series has been ready there. What's left is that we need to set this series to the chart, right? So we need a chart. So in that case, we were saying that chart areas, not chart area, okay? So we will ask that, so if it is populated up to this point, clear, then, all right, so populate data. So let us take care of this function first. So since this function has not been defined yet, right? So we can let the Visual Studio help us. Highlight it, right click it, quick action and refactory. Generate method, okay? So we let the Visual Studio generate this skeleton, function skeleton for us. So right here, get membership degree. But right now, by default it's private. So I ask it as a public virtual. So implementation is that throw an exception, no implementation exception. Okay, so fine. So we get membership. So right now we do have a get membership degree function ready for you to populate your series point. Okay, so we have this function, right? Oh, okay. So when instantiate this series, then we can call this function populate membership function point. But what's left should be what? Should be well, once we created create this fuzzy set, universe has been specified. So we need to add our series to the chart area. But the chart areas is not the one, because we need to add our series to the chart, not chart areas. So okay, if the user, in user interface, they provide the chart, right? So if they like this fuzzy set displayed on their chart, they need to provide chart for us. Okay, all right. So in that case, we should do what? We should provide a function, right? Provide a function. That means right here, provide public void add series to chart. So user needed to provide us a chart, CHT. So in this case, we kind of invoke a chart series, add the series. Not just that, because right now our chart have a bunch of what? Has a bunch of chart areas. You need to specify the series will appear on which chart area. So we need to know this. Well, let us when we instantiate. So chart series right here, chart type right, popular point here. We need to specify the chart area's name. The series has a property called chart areas. Actually, it's a string. So in string needed to set to the chart area. The the universe. The areas. Okay, so we need a function to. Okay, we ask the universe. The series. Okay, we ask the universe. Tell us the chart area's name. So let us go back quickly to the universe. So universe has a bunch of data, right? They have a node and area. So we ask the universe to provide another property. So this property is called public string area's name. That is very simple. It's just get. So simply return the area's name. All right. So back to here. So we need to assign the series. Eventually, will be associate chart areas with the universe area's name. I will say it again because right now our chart has a bunch of chart area, but we just have this chart just have a series collection. So if we add a series to this series collection, by default it will show up in the first chart area. But right now, our fuzzy set the series belong to certain universe, right? So it will have a particular chart area to be associated with. So that is the point we like to have. So short curve and setter is right here. So we will have a flag short MF curve, right? But we don't have it, so setter is here. And get does not have it, but we will have initial value get. All right, never mind. We just put a private for show MF CUR. Initially is false. Initially is false. Okay. So this is setter, and how about getter? Get. Simply return this show lowercase this boolean value. So we have we have a property here. Okay, so far so good. Up to this point, we have constructor, generic constructor, and we have a Gaussian fuzzy set. We have defined a function, right? Which function? Get members degree right here. So it's about the time we overwrite the Gaussian function, right? So Gaussian function right now we have parameter value 0, 1, right? It's ready. So type the keyword override space key. Try to override what? This function. Get membership degree. Alright, so you put what? Since right now you are in Gaussian fuzzy set scope, right? So wait a minute. Okay, we can implement it directly right here. So return what? Return, I cannot remember exactly. Mass exponential, right? Minus 0.5 times x minus parameters 0 because it's center, right? Time x minus parameters divided by parameters 1 is a sigma divided by parameter 1. Alright, this is overall the member function. How about the name? We try to set up the name, okay? So, similarly, the name should be put in here. Let me use it here. So, Gaussian fuzzy set, we have static, int, let's say count, current count. You can use different names, okay, count equal current R1. So once I initialize everything, I should set my name. So we should have a name associated with this class. Okay, so here, data field. I like to add a protected. Yeah, string name. Okay, so we always instantiate an object derived class. So counter one is here, and then so we have a name equal what? Equal Gaussian. We use switch string Gaussian current count plus plus. So we have name specified. Since we have name specified, so our name in series should have a name associated with it. So new it, and the series name equal name. We need to assign it because sometimes the series is not instantiated, so we need to have our own name. We cannot delete and directly use series name because series will take up a lot of memory. So if we don't need to show the code, we just hide it. We are not going to instantiate it. That is the idea. So we need to have our own name characteristic data. So right now we have it, and then what we should do is that chart, right? So we have so we assign series to chart. Chart we add it. So this function is ready for the user interface to add this fuzzy set back to us. So let us take a look about the usage. So we come back to the main phone right here, and suppose there is a button right here. This button add. And move it back here. So this function is dedicated to create a fuzzy set, in particular Gaussian fuzzy. Call it add Gaussian fuzzy set. But before it quick, definitely we need to select universe. Okay, so far we can create universe. There's no problem. Create universe. So suppose the user click on universe 1. Right, this is the universe property. And then since it's correct, it is selected, so we know the selected node of this guy, right? And through the node tag, we know the universe. So right now, if a user want to add a, for let's say mini node, it won't create a Gaussian Father set on this universe. So the target universe is very important. How about this quick event? So this quick event can be done, double click it. So right now, I add here. So I create a Father set, right? So Gaussian, particularly Gaussian Father set, GFS. New. Take a look at your constructor. Wow, I need a universe. So where did you get a universe? I need to have a universe, right? Alright, so universe, where is the universe? Selected U. Well, where can I get the selected universe? From tree view, TRV, tree view model, right? Tree view has a selected node property. This is the node selected. So remember, there is, because we kind of store our reference or the universe in the tag, right? So tag is the one that universe, but it's violated the rule, right? In the left hand side, it's a universe reference, but in your right hand side, tag is that tag is an RBJECD, is OBJECD. So type does not match. The compiler will not let you do that. But usually, we know the tag definitely is a universe, so we can cast it. So you can cast the tag as a universe to let this statement valid. So it's okay. Or use another operator called as. Both of them will work, okay? So either way you cast it or transform it as a universe. So right now we have selected U ready, okay? So then we can invoke this constructor, put selected U within it. So right now we have a Gaussian Father set created. It is created, right? Okay, let us just step by step exercise what happened. Create universe, create another universe, create third universe, select universe 2, select universe 2, right? Select universe 3, universe 2. Right now we are about to add a Gaussian Father set. Alright, so at first we will check the selected node. There are selected the text, the face text U2, right? U2. How about the tag? Move your cursor into tag. Wow, it's a universe U2. How about the okay, tag is U2. So there is no problem. So once we execute this line, initially it's none, right? Once you execute it, move your cursor to select U. Oh, okay, universe 2 has been recognized, has been picked up, has been selected. So we are about to use this as the parameter to construct a Gaussian Father. So I hit F11 key, right by now executed. So we came to this Gaussian Father initial constructor. Before that, we pass U in, right? So U right now is U2. So this constructor has not been executed yet, but because it's a derived class, right? So we need to take care about the constructor or the parent inherit part. So we are about to execute the base U. So pass the U here is U2. Let me hit F11 key again. Came to the genetic Father class. So we try to initialize every data of this genetic Father. But because we have initialization statement right here, right? So this initialization statement or the parent or the genetic Father set will be executed, right? So show curve is false. All right, so we are about to execute this constructor or the genetic Father set. Universe 2 is U2. You see. All right, so the universe initially is none right now. This is data or genetic Father set. Parameter still none, right? Okay, series is none. Show curve is false. Name has not been specified yet, right? So up to this point, the universe has been confirmed. The universe is U2. All right, so we complete the constructor of the parent class. We keep going on with the constructor or the derived class, take a look at the current constructor. We have local variable u, local variable u. We have the whole fuzzy set data right there. So unfortunately, you will see we do have a parameters inherit from parent. Current is none. We have a name inherit from parent. Current is none. We have show MF full type. Current is false from parent. We have the series initially is none. Right? We have the universe. Okay, has been assigned in the parent class. Fine. We have universe U2 ready. So you click on these are the property of the universe 2. So far we have here. So it is about the time we instantiate the parameters because right now we are Gaussian function, right? So we need to double. So parameter 2 has been created 0, and then initial value has been assigned. So name we kind of use Gaussian 1, Gaussian 2. So up to this point, an object of Gaussian fuzzy set has been successfully created, and knowing that this fuzzy set is defined on the universe U2. Oh, okay. So check about the data up to this point. We have we did not show MFC, right? And the series is none, right? So we're not going to show it, right? By default, the universe has been specified, parameter has been specified, and we have initial value is legal. We have name specified. Okay. Up to this point, it's okay. So fine. Up to this point, an object has been successfully created, but it will not show up in the user interface, right? Yeah, we know that. Okay, we did not do that. So since we are creating the primary fuzzy set, so we like the curve shown up in the figure. So up to this point here, we use the object name Gaussian fuzzy set object dot sh is what? Sh property show members function curve. Set it to true, and then ask GFS. I think there is a function add the series to chart, right? Well, remember that this function belongs to main phone, right? Main user interface. Main user interface has a chart, so this function will ask this fuzzy set add your series to my chart. The chart. GHT fuzzy set model. So I added your series to my series collection. Now I will show you a members function on the curve. That is idea. Okay. All right. So create universe. U3 add a Gaussian fuzzy set. So I'm not going to enter that function. I just hit F10 key. Okay. It is about the time we change this flag, right? This property. So let me hit F11 key. Go to Gaussian fuzzy set. That should came to here. All right. So let us go back to the main phone. I'm about to hit the F11 key. Alright, so F11 key, I try to change the show MFC curve property into true, right? So right now my value is true. And since the series current has not been instantiated, none, so it will dynamically instantiate with the series, new series, set chart property. Okay, I'm about to populate the point. So I hit F11 key again. During the property change, a lot of function has been invoked right here, and this is one of this function. So I kind of populated the point one by one. So series right now has been instantiated, right? But its point, we click on its point. Then we check the universe, the minimum value U3, right? Minimum value 0, minimum value max. Oh, I made a mistake right here. We're not going to have any data. Max, that should change to maximum, right? Okay, let me terminate it, change it again. Increment. Okay, let me set a breakpoint right here. So let us quickly come to this point. Create a universe. So right now, suppose I have choose U4. Okay, go in. All right, so we are about to populate data. So right here. Okay. How about get membership degree? As you can see, in generic fuzzy set, there is a function get membership degree, right? But without any implementation right here. But it's have been declared virtual, right? Virtual get membership degree. So will this function invoke? Or this overrider function will be invoked. This one will be invoked. All right. So it run to this point. So when I run it again, if I hit F11 key, come to this override function. So it's very important. I mean, if you have familiar classes, and in the parent class, we usually declare that as a virtual function. Virtual function, that means, well, probably they have some information, default information there. But usually, if a child class does not want to use the function inherit from the parent, the child should override that function. So definitely, we will override it. Every Gaussian function, every fuzzy set should override this function because you have your own membership function, right? So we kind of through this virtual overrider mechanism to fulfill object-oriented so-called dynamic binding or polymorphism. This kind of characteristic of object-oriented technology, polymorphism, or we will call it dynamic binding via this virtual function and override function mechanism. Okay, so let us keep going back to here. Let us execute this to this line end, this function end. Okay, because there's a breakpoint, I kind of disable it. All right, we end up this function call back to where? Back to the setter. So during this setting, a bunch of function has been executed, right? We instantiate a series, we populate the series point, and then we assign the chart area because it's initially non-string. Right now, our universe has a name, right? Chart area 4, so name, the series name it. So we simply change this property, but a lot of computation has been done here. So the final step, we add this fuzzy set to this chart. So we enter this function. This function, so that what we do is that we just populate this is the series, right? To add the two chart areas series collection. Fine. All right. So Gaussian function has been popularized here. It looks small, but it's working right there, right? Right. So maybe we try it again. At a universe, at a second order universe. So suppose we click on the first one, at a Gaussian fuzzy set, terminate the breakpoint, disable the breakpoint, continue. So we see the Gaussian function has been shown up right here. How about the U2? If I added U2, and if I add another Gaussian function again, to where? To the U1. So U1 right now has two object of Gaussian function there. Yes, right? There, right? So how can we change the parameter? Right now we just have U1, so we can set the parameter U1, right? How about the Gaussian function we just added? So if we can add a tree node, sub-tree node, then we can click on it. We can set property, right? Yeah, that's the whole idea. So let us go back to the this add function. So we kind of here, right? Remember that we first identify the node, right? Selected node. Since it's the universe, we'll pick up the universe, then we add it. So right now, since the selected node is there, so we create a fuzzy set. Similarly, we kind of what? We kind of create instantiate tree node. Tn equal new tree node. Tn again, we use its tag. Secretly store our GFS there. GFS there. And then we need to what? Add this tree node to this tree node will be treated as a children node, right? Children node or this selected node. So right now we have selected node. So okay. So since Tn is ready, tree node TRV selected TRV for the model selected node. The nodes add Tn. So that will add a sub tree node to the selected tree node. So it will happen there. Okay, so we create a universe, create another universe. Suppose in the first universe we add a Gaussian Fuzzy set. See, there is a sub node attached to the U1, but unfortunately we cannot see the name, right? So we have better specialize the name for it. Yeah, right here. Tn dot name. Excuse me. I cannot remember. Should be text. Do I have text? Yes, we have text. Tn the text. Let me see over here. Tn. Okay, that should be the name, right? Equal what? Equal GFS name. Oh, unfortunately, we did not specify the name property, right? Okay, so we need to go back to our Gaussian Fuzzy set. Back to the generic Gaussian Fuzzy set. So we have property show curve right here. We add another property public string capitalized name. It's very simple. We might need to provide setter and a getter. So if you want to get, it's very simple. I simply return lowercase name. You want to set the setter. So setter, our name will be changed into your value. UE value, and I also if the series non-equal none, meaning what? Meaning it has been instantiated. I need to change the series name again. Name equal name. Make them consistent anyway. All right. So our generic Fuzzy set do have a name property open to the public. Okay, I have L, combination L list right here. Okay, right here. All right, so I can use the property set the tribute node. So probably we need, in order to let the name change working in both directions, right? So similar to the universe. Universe has a what? Has a tree node, right? So we kind of copy that back to our Gaussian Fuzzy set. So Gaussian Fuzzy has data field protected. We always start from protected. Tree node is not recognized within this file, right? Never mind. We let the wizard add this using statement for us. So we have the node right here, and I think we need to provide another function, right? In the universe, how about this node? We have set tree node, right? So similarly, we copy this function as a public function or Gaussian Fuzzy set. Since we have this data, we needed to provide public function. I'm putting here set tree node here. Okay, so during the construction, back to our construction, once we create the Gaussian Fuzzy set, the tree node name, take it, and then we ask a GFS set tree node is TN. So this mechanism is exactly like the what we have done in the universe. So you can carefully change that. So where U1, U2, so we click it, U1, select this guy. Okay, so we have it there, and then unfold it. Wow. So probably it's not name, that should be text. Should be the text. Sorry about that. So not TN, should be the text. Or the easiest way, if you take a look at the code in creating a universe, we just invoke this constructor. Constructor need a string to display it on the control. So we use this way. 1, 2, the first one. So click it. Yeah, that's it. So we have Gaussian one ready, right? Okay, interesting is that, well, remember that once we click this guy, this property will show up the property that can be changed of the U1, right? So if you click on U2, you see U2. How about Gaussian one? You click on the Gaussian one. Wow, it's property, right? Gaussian show membership function. Why it is false? It's interesting. We have been set that into the true. Interesting. Let me check. It's not consistent. Let me check out what for this set. So, oh yeah, that's right. You see, this Gaussian for this set, we have property setting right here. See, right now value is true, but we did not set it, so I need to set it. Our lowercase show, let's say into value. Yeah, we need to update. And if it is true, then we need to do another thing. So actually, I should put in here. Because the user can arbitrarily set this flag to true or false. So we can say if show MF membership function curve is true right now, I need to update. If the series is none, I need to do it. Else, maybe you should delete that point. I don't know, but again, we just leave it there. So user can supply a new value, either it's true or false, to update our lowercase show membership function. Okay, if it is true, then if the series is not instantiated, we need to populate it. So in this case, we populate it, right? Okay, so we have added U1, U2. Suppose select U1 at the Gaussian for this set, and click on Gaussian for this set. We will see Gaussian. How about we change the name? Will that be okay? I don't know. Maybe I call it hot. Enter. All right, it changed, right? Hot. How about this guy? No why, right? It's very simple, right? We just go back to our generic file set. Always deal with generic file set. We have a name change. So I have a name change, right? I have a name change, and I also change the name, right? And I just update what? Update the node text equal name. Just change it. I think that we're done. So pretty good. U1, U2, U1. Suppose I change U1 into pressure, right? It's pressure. And suppose user set pressure, add our Gaussian for this set, and saying that this is Gaussian one, only a Gaussian one, but Gaussian one has been changed into hot or high. All right, everything is consistent with that. So what's left is what? If user like to change the center, or change it, or probably I call it mean. Anyway, mean, and the standard deviation. Well, nothing popped out, right? Remember that in previous assignment we needed to provide a static call parameter names, right? But right now, since we have the mechanism property, well, you can see what you needed to do. What you needed to do is within Gaussian function, you kind of region property, add some property here. What kind of property you will populate? Well, refer to the parameter 0, right? So you will add a meaningful name of this property. Public double mean. Okay, how about mean? If user want to get it, return what? Parameter 0, right? Parameter 0. If you want to set a mean. Well, I don't think user might provide a minus infinity up to infinity. That would be okay for you, right? Even though right now our universe has a minimum 0, maximum, but it's okay, right? User can arbitrarily set the value of the mean. So I'm not going to set up any restriction rule. I directly set my parameter value 0 equal value. Okay, it's fine there, like that. How about standard deviation? Well, standard deviation should be better specified without any negative value, right? Standard deviation should be positive, right? So I have another problem named standard deviation. Standard deviation, or properly in short, STD. But I prefer use TND, the standard deviation. It's much more meaningful. How about that? Parameter 1 into what? But I will have a guarding condition if value large than 0, or large or equal 0, probably than 0. Only in this case, I will let it change the parameter 1. So parameter 1 is standard deviation, it's mean. So later on, if you deal with the triangular fuzzy set, remember that you have left, you have peak, you have right? But you need to do some parameter value integrity checking here. Only make sure the new value does not violate your rule, because depth should be smaller than the peak, smaller than the right? So you need to deal with that in your theta function in order to make a seamless or faultless parameter setting scheme. Okay, a mechanism there. Okay, so I have these two properties added, and I can change it. So add another property, another university, add the universe unit Gaussian. So Gaussian right now we have property ready for us to set mean 5, right? Standard deviation 1.0. If I use a special minus 50, will that work? No. User try to hit some other place, try to change it. So 1.5 still there. So if 99, it is illegal, right? So you are not going to change it. So it's good right now here. And standard deviation. So, but as you can see, I have changed the center into 3. What happened? Nothing happened. The series is not updated, right? So what should I do? Well, since your parameter has changed, right? The standard deviation has been changed. So you need to change the series, right? So again, back to our parameter setting. Mean parameter has mean and standard deviation has been specified with here. I mean, by the Gaussian fuzzy set. But in generally, Gaussian fuzzy, triangular fuzzy set, another fuzzy set should have the same situation, right? So back to our genetic fuzzy set, we should provide what? Provide a parameter changed function. Okay, so here we will have we will define. Well, it's again that should be the helping function. I kind of unfolded the name and populate service function. Okay, here. So populate MF point, right? Populate MF point. So populate point, right? Okay, so popular point. All right, so I might provide protected okay, protected void P-A-R-A-M-E-T-E parameter C-H-A-N-G-E-D parameter change this function. So if for a generic fuzzy set, if parameter change, meaning what? Meaning if our series is non, if our series is non-null, we need to recalculate all the point, right? So populate the point, right? Populate point, create everything return. So if the series non-equal none, so that means the series has been populated somehow because the user want to see it, see the function membership function curve. If not, then I need to populate MS point. That's it. So parameter changed. So back to your back to where? Back to your Gaussian function. You let the user change the mean, right? So you really change the value, right? So in this time you will invoke the inherit function, parameter change function from parent. So parent really change, right? But again here parameter standard deviation, right? If the value larger than value, so you allowed it to change it, and if the parameter change, you will call this function because the your series might be displayed in some other place, so we need to update it, right? All right, so let's see what will happen. Add a Gaussian function, right? Gaussian function here. Select Gaussian function, and the Gaussian function has changed its mean into 8, right? So it's about fire this property change event when user click another place. So A has been changed, right? And if user change the standard deviation into maybe 1, click on some other place, activate it, so it's 1. So I'll pop it into 4. Right, so we let the user change the parameter via this property grid. Everyone will be happy. And how about the U1? Change the name. So this is the temperature, right? But the problem is here. If user change the minima value because temperature has minus value, change it into -10. Will this change activated? It's okay because -10 do smaller than the current maximum value there. Yeah, right. So if I click on some other place, well, no problem. -10 has been changed. But what about your membership function? Kind of miss, right? The order miss is 0 start from 0 up to this point, right? So it's not full on. It still has certain kind of inconsistencies, right? So we need to remedy this situation because right now user can arbitrarily change the parameter or Gaussian fuzzy say change the parameter temperature. We need to make this graphic displays consistent with the change. So the problem came out, well, your fuzzy set depend because a fuzzy set defined on a universe, right? But if universe change the property that were related to your display, then we need to know it. We need to know the parameter of a universe has been changed, right? If the universe can fire that event, that parameter change event, let us know. Then since we are the fuzzy set, we can subscribe the event change event, then we can do something. That is the whole idea. All right. So it is about the time we talk about the so-called delegate in C# programming language. delegate is a data type defined by the user, just like the class. You can define a new class name, right? And intrinsically, a delegate is actually a function pointer. I mean, if you are familiar with the C or C++ programming language, there is a variable type called function pointer. So function pointer is a variable. Right now, we can point to function A. Later, this variable can point to function 2. So a function pointer can be executed just like a function invocation. So in C or C++, we call function pointer. But in C# programming language, we call it delegate. So a delegate is a data type specified by the user. And then you can use this delegate pointer to store a variable to store the function. So once this delegate is executed, actually you kind of invoke that function. So delegate, try to think of that as a function pointer, but in fact it's a collection of function pointers somehow. Later on I will show you. And even though it is new to you, but actually it's not new for us, because as you can remember in the user interface, we drag a button, right? And then we subscribe its event. So right now it's about the time we add event to where? To universe. If a universe parameter change, then we can subscribe it. All right, so how can we add an event to a universe? What is the event? Event is actually a delegate. It's kind of complicated. But if you want to define an event, you need to make sure the delegate. So delegate, you can design your own delegate, or otherwise use standard delegate that has been already existing in Dynamic Framework. So right now we try to add an event called parameter change event, and the event will be associated with a delegate, and we use the standard delegate. Okay, all right. So let me show you how to do that. So we come back to the universe. So our universe is right here. We have property, right? Well, let me organize a little bit about these parts. This part is region property and event. Right now we try to add an event. So this region is here. So we unfolded resolution, unfolded increment, unfolded name, unfolded maximum, unfolded minimum, unfolded up to this point, up to this place. Okay, region. And all right, so this region of property and event. So right now we try to add a property. Public event. Right now you need to specify a dedicated type, and we like to use event handler. Okay, you see a shooting case icon. That means it's delegate. So it's a delegate. It's a delegate. Event handler delegate. I call it PARAMETE per CHANGED. That's a parameter change event. That's it. Very simple. But when this parameter change event do have subscriber, later on we will subscribe it. So let us see step by step. So right now the universe has a public event. The name is called parameter change. Okay, let us go back to our main form. So when we create an object, right? When we create an object, so when we create an object, see where when we the constructor, the constructor of genetic fuzzy set. Genetic fuzzy set, the constructor right here, right? So user supplies a universe to us. Then, okay, this is Gaussian. Let me go back to the constructor. So how can you do that? Highlight it, right click it, go to definition, All right, this is the constructor of the genetic fuzzy set. So right here, right now, we know, okay, universe has been passed in, so we assign to our universe. So right now, it's about the time we subscribe event from universe. All right, so how can you subscribe it? The universe dot. So right now, as you can see, the universe class has been designed by us, right? So we had a bunch of property. We add actually we did not add a function. We do add a function set tree node. We add a property. See, there is a Thunderbolt there. So we subscribe this event. And if you want to subscribe event manually, programmably, what you need to do is add a plus equal. Plus equal meaning what? Meaning the parameter change actually is a correction of function pointer. We try to add another one. So click on the space key and then hit tab twice. Oh, okay, once will be enough. So don't worry, because we just didn't knowing that you won't subscribe a parameter change event. So we just did prepare this function for you, even name a meaningful name for you. The universe parameter change. This is function provided within your genetic Gaussian fuzzy set. So we subscribe this event. So once this event happens, then it will invoke this function. So we subscribe the universe parameter change event right here, and we need to do something. Right? Since the parameter change has been changed, right? So again, similarly, we need to check if the series non-equal number. We need to populate its point, right? We need to recalculate the point, right? So populate MS function. So populate up to this point, you does not have any idea. But let me set a breakpoint. Let us trace it. Okay, parameter change, right? Okay, so as usual, okay, we have L. Alright, so we kind of add a region, and some region is missing in the region. Okay, so new region start from here. I don't see any L. In the region directly expanded. Okay, start from beginning. This is start. This is end. Something screw up. Okay, maybe. If I remove it, what would happen? Well, I need it because I do have a region right here. I kind of, okay, I unfold this. So, outline, toggle outline. Okay, let me check one by one. Control F, find key. Region. Oh, okay, another region came here. In the region. Typo, it's a typo. So, all right, these are all regions. So let me start again. create universe. I define within this universe. I define a Gaussian. So right now, if I change the parameter, it's okay. I mean, it's change to 8, right? But user might click on the universe change property. For example, minimize into 18, maybe 10, enter. That's the problem, right? But right now, even though we subscribe the event is not fired. It's not fired by the universe. So even though we do subscribe, but it is not happen, right? The line is not regenerated, right? So the problem is that the mechanism in the universe is not complete. So remember that what we just have done is that we just added this parameter change. This is the event. You see, the green carrier came out saying that, well, you kind of define it but never use it. You see, you never use it. We need to use it because right now in our scenario is that our file set once it is instantiated, it subscribe this event, but we need to fire this event. So where is this event should be fired? Parameter change. Area name is not so important, right? Resolution, yeah. If resolution change, we need to fire this event. How about the increment? Increment is read only. It is not set, so does not matter. It is not changing. So name, probably we should do that, but maybe not. But most important should be maxima value change, right? Maxima and the minima value change. If it is changed, then we need to fire. Fire this event. So how can we fire this event? This is the event, right? But actually, I say, well, event should intrinsically actually is a delegate. Delegate is a function pointer. But in C#, actually, you should say that it's a collection. It's a collection of a delegate. So if one object subscribes this event, then that object should provide a function. So we create a function pointer here, put it here. Another object also subscribes this event. So a bunch of probably more than one object will subscribe this event. So we need to fire it. How can we fire the event? During, for example, solution, right now solution has been changed, right? So we will fire this event. So how can we fire it? If we check if parameter change event, this is event, right? Non-equal none, but in fact it's a delegate. If it is non-equal none, then we fire it, just call it. Just like a function, like it is function. See, this function taking two arguments. Sender might be sent to this event none. I do not pass any variable information for you. So that is not equal none. Excuse me. We fire this event. So when the resolution change, I fire this one, and maximum value change, right? Maximum value change. I fire this event. So let me set a breakpoint here. And minima has been changed via this event too. All right, so let us go back to the interface. So U1, U2, U1 add a Gaussian file set. I can change the parameter, right, into 6. So that has been changed. Right now, I select the U1, change the minimum value into -10. Click on some other place. Will fire this variable property change setting. So come to here. I try to change the minimum. What is the new value? New value is here, -10, right? So right now the minimum has been changed into 10, -10. So we are about to fire. And we do subscribe this parameter change event, right? So move your cursor into this parameter change this event. Well, there is a method. Method is where the universe parameter change this function has been subscribed. So let me hit F11 key. Hit F11 key. Came to where? Came to this function. You see this function when we instantiate a generic file set, right? We subscribe it. We subscribe the universe parameter change event. We we prepare this function, add this event handling function pointer to your event, parameter change events. So we use plus equal. That means we add in this event. So right now, since you fire this event, so you came to this point. So since our universe is non-zero, so we populate the point. So point will be updated. So through this mechanism, we kind of updated it, right? So probably you change your measurement into 20. Fire it. Again, the parameter is fire. This event is fire. So invoke the function we provided. So the reason is that because myself is a Gaussian fuzzy set, right? Gaussian fuzzy set depend on universe. If universe change the parameter, they need to inform us. So they will not inform us, right? We need to subscribe their event. So the responsibility of universe is that the universe needed to publish an event, and when other guys needed to subscribe the event, then they will provide the function to update their data. So that is a mechanism we have been using. I mean, when we drag a button into our form, we subscribe the critical event. Similar. So right now we kind of design our own class, and we needed to knowing that maybe some other class will depend on your class, and in your class, this change, this property change is meaningful. It's very important. So you need to prepare. You need to design an event to let the user, subscribe this event, and then also you need to fire this event. So for a universe, because the important change is very important. So in the universe, we define a parameter change event, and in property in proper place, you need to fire it. So when this event is fired, that means the user supplied function, the function can be called by the universe. All right. So let me take out this breakpoint. So everything is working there. All right. So how about 100? Yeah, it's okay. This night will be updated too. Okay, I think up to this point, the technique that I'm going to deliver to you is done right now. So not just add a Gaussian function, right? You need to add a combo box, list box. The user select a universe and select a type of Gaussian function. Click on this button. So either Gaussian function will be added, or triangular function will be added, or left right will be added. Okay, the rest of them you need to complete it by yourself. Try to see. Well, I might provide you a simple application so that you can populate the rest of them. So you need to do the rest of you, not just add a bunch of at a button. You need to prepare properly. The best way is try to provide a combo box. So show up the available type of Gaussian function, and this button will check about which one will be selected, and either add a Gaussian function function set, or add a triangular function set, add a trapezoid function set. Okay, make this mechanism work seamless or flawless. And I think the due date should be 10 days from now. So the deadline is not Saturday, so it's okay. I mean, next week we will have a lab time. We will see. I will see whether you have any particular problem. We'll try to solve it. So rest of them you need to complete it by yourself. So what will be necessary for you to do? You need to complete others fuzzy set. So right now, what I have shown you is a Gaussian fuzzy set. Unfortunately, right now, my Gaussian fuzzy set has been written in this file, right? Gaussian fuzzy set. So don't worry, okay? So right now, I just have a Gaussian fuzzy set CS file, right? So never mind. We'll let the user do that job for us. Okay. Okay, when this driver came out, this icon, right? Click on it. Click on it. Okay, move type, because right now in this file I have defined a Gaussian fuzzy set class, right? Move type to another C# file. Fine. Okay, this is the one I'm going to use it. So click on it. Visual Studio will move this class definition code into another file here, Gaussian So I have a new file, Gaussian contain all the data here. Okay, give me a second. So what you need to do, for example, click on this project file, add another class, try Angular fuzzy set, right? Similar to the Gaussian fuzzy set, right? Inherit from what? From generic fuzzy set. All right. So what's left? You need to provide constructor. Do your own initialization and implement override function. What you need to do is that, so check about the Gaussian fuzzy set. It was very simple for you to implement all the rest of the fuzzy set, and you can try it on your interface. So right now, you will complete most of the functionality about building up a fuzzy inference system. Okay, so the rest should be your job. Just try to. I know a lot of new stuff has been delivered to you, but step by step, gradually, get familiar with this kind of scheme. Okay, since we are dealing with so-called WinForm application, we always has a user interface. Sometimes we hide our object reference into this control. It's usually later on we will add the unary operated fuzzy set and binary operated fuzzy set. Remember that we have cut, right? Cut fuzzy set, and we have a union to find a union. So after the union, we have another fuzzy set generated. Okay, so we will keep populate our fuzzy set class level by level, step by step. So you need to complete it up to this stage and complete the user interface and try to beautify this layout. Okay, I might teach you how to arrange because right now we have a bunch of user control right here, right? So the easiest way might be use all right, I will let you know some techniques later. Okay, so for the functionality requirement up to this point is enough. So probably in the next assignment I will teach you how to arrange this control in an organized way and take advantage of a big screen somehow. All right. So for assignment 3, I think up to this point will be okay. So carefully size or resize your tree view, your public grid, and your chart in a good-looking way. Okay, that will be okay. That will be enough. All right. Okay. So that will end up this video.